Now come to the properties of aluminum copper alloys. So what are the properties? The high strength and hardness. Okay, so copper strengthens aluminum by forming a fine precipitates which improve the mechanical properties. So incorporating the copper into the aluminum, that we are having a more strength. So the strength of aluminum will get increased when we are on incorporating or where we are alloying aluminum with copper. Okay, so some aluminum copper alloys can achieve strength compared to the mild steel. Okay, when properly heat treated. So once you have an alloy, and then you need to do some heat treatment over this particular alloys, then the strength of that particular aluminum copper alloy would be as as much as the mild steel has. Okay, so we can reach the strength up to the mild steel strength. Okay, so this is very good. Now good fatigue resistance. So these alloys performs well under the cyclic load, making them ideal for other aerospace and automobiles components. Okay, I have already made you know that all of the real components in practical life, they are having experience of dynamic load, and due to dynamic load, we our component will experience a fatigue failure. To resist that fatigue failure, and that fatigue failure is at a very less stress as compared to the normal loading. So suppose if the same material are having experiencing 100 kilonewton, this is 100 megapascal strength, suppose. Okay, this is their yielding point. Okay, but the same material, when they are in dynamic condition, they will not be sustained to the 40 megapascal. Still before that, they will break, or they will fail. So that kind of the failure must be avoid, and for that we design a material that could have the higher resistance. It doesn't mean they will cross the 100, no, but if they are having a 40, then if it go to the 60 or 65, that it would be sufficient. But also in whatever the situation or whatever the condition, but they always be less than of building strength or normal loadings. Okay, so in fatigue or dynamic loading, always your material will fail before the elding. Okay, now heat treatment. So if we talk about the heat treatment, sorry, heat treatability means how how much and what are the possibles of feasibility of that particular material to get heat treated. Okay, so most of the aluminum alloys can be strengthened through the precipitation hardening, edge hardening, significantly improving their mechanical properties. So heat treatment can be easily performed over the aluminum copper alloy to get the more strength. As I already made that if we properly you know apply the heat treatment, then we can achieve the mild steel strength in the copper aluminum alloy. Okay, now moderate corrosion resistance. So corrosion resistance, I have taught you many times what corrosion and what is corrosion resistance. So we are having need of material that must have be corrosion resistant. So their material will not get corroded and material will be safe. Okay. So while aluminum copper alloys have been decent corrosion resistance, they are more susceptible to corrosion than pure aluminum or aluminum magnesium alloys, especially in the marine environment. So what they are, having their specific properties, that they are having a more corrosion resistance. It's as compared to aluminum. So aluminum itself, whatever the corrosion resistance they are having, the more than that the aluminum copper alloys has. Okay, and if take the example of aluminum magnesium alloy, then also as compared to the aluminum and magnesium alloys, the aluminum copper alloys have more corrosion resistance capabilities. Okay, so that's why it is being used in marine environment. Marine environment, they are going to use in a sea, or sea waters. Okay. So due to the environment, every material gets corroded due to their environment. Okay. Environment is just a surrounding which is near to your system, right? So whatever the application part of your material is, that is your system, and rest all the things would be counted as a surrounding. And the surrounding which is very near to the system, which is going to be affected, or they will affect the system. Either they are going to get affected, or they are affecting the system. In the both the cases, they are known as the environment. Okay. So there are, especially in marine environment. So in general, we are having atmosphere, which is air, okay, in our environment. And if we talk about the marine, it means they are having the water, and the water is of saline water. They are having the more salt in their mixtures. Okay, so often coated or iodinized to improve the corrosion resistance. Why we do the anodized to improve their corrosion resistance when they are using in saline waters. Okay, so good machinability means I already made if the material is going to have a more ductile, then it means they can easily be machined. Okay, so if I mean brittleness and ductility, just opposite sense. And if the material is more brittle, it means they could not have in the machinability capacity is less. And if they are ductile, then it has a more capability of having machined. Okay, so these alloys are relatively easy to machine. It means they are comparatively ductile materials because it is easy to be machined. Okay, so making them suitable for other precision components. So whatever the if if a material is having a capability to get machined easily, it means they are having ductile, and we can make any kind of other component of our precise or precision components, or whatever the component that we are need. Okay, so moderate to the low ductility. Okay, if it has been already mentioned here that easy to machine, it means they are ductile at least. Okay, but how much they are having ductility, that will depend on other things. Okay, so they are having moderate to low. So they are not a good or too much ductility they are having. So they are less. You could say it's such a kind of a, having in between. Okay, so ductility is not too much high, not too much low. Okay, so the higher strength aluminum copper alloys tends to having the reduced ductility. So whenever we are increasing the value of the copper, it means we are getting the higher strength, but at the same times we are reducing the ductility. So why it is written moderate to low? When in case of the less amount of copper has been mixed into the aluminum, then it would having a low, as compared to the other things, they are having the less strength, but at the same time they are having the moderate ductility. But opposite to that, if we are having more and more copper into the aluminum, then it would having the higher strength, but at the same times that we would having reducing, or we would have reduced ductility. So ductility would be not as compared to not as much as we were having in a low carbon. Sorry, at a, yes, at a low carbon, low copper. Sorry, we are discussing the copper. Okay, so which limits their use in application requiring extensive performing. What does it mean? It means it depends what the kind of the alloy that we are having. If different percentage of copper is is there, then we could have a limited ductility. If less copper is there, then we would having the high ductility, or moderate kind of ductility as compared to the high copper alloying element. And if it depends on our application part. If ductility is required, then we must having the copper in a less amount in aluminum. But at the same time, we would have to compromise with the strength. Okay. But if in case that we are need to have a more strength, okay, as then we need to incorporate more copper. Okay, so that I mean we have discussed just in a previous slide that by incorporating the copper and copper into the aluminum, we could reach up to mild strength. Okay, so so it depends our application part what we are designing right now. Okay,